Hi, in this video we will compute an approximation to number pi using this theory that is different from the one that we have already seen this academic year. Thus, the approximation to number pi will be computed as the square root of the theory times 16 plus 8. The novelty in this exercise is that we have to perform this approximation using a function that has been declared as compute p underscore n terms. And the input parameter will be the number of terms in the series, and the output parameter will be the approximation to number pi. Okay, so let's start opening Matlab and setting our default folder, which will be problem 2 in the desktop. Okay. And what I suggest is to start writing the function and then writing the main script that will call the function. So we will create a new script. Then I will use the declaration of the function. Okay, so the first sentence must be function and then the declaration of that function. Okay, good. I have to correct this underscore, and n will be the number of terms. So what we will do is we will set an initial value to sum, which will be 0 because we are computing a summation. Then we will loop for I equals 1 until the number of terms, and in each pass through the loop we will update the value of the summation. Sum is equal to sum plus, and now the expression is a little bit more complicated, which is 1.0 divided by something. Okay, and let's write this something. And this something is the first term will be 2 times I plus 1, and we will multiply it by the same amount because it should be to the square, and then plus the same quantities but with minus 1. So I copy them, I put them here, and I change the plus by a minus. Okay, so what we have is the sum, the new value of sum will be the old value of sum plus 1 divided by this quantity. Let me put here some white spaces in order to make it clear. Okay, so maybe this will help to read the code. Okay, is 1 divided by, then this is the amount which is composed by two terms, this one plus this other. Sorry, I think it's not plus, I think it's times. Okay, so I correct this, it should be times. Okay, so this is the summation, and then what we will do is to compute the approximation to pi, that it must be called p, because this is the name that we use here as output parameter. So p should be equals to the square root of, then I think it is 16 times the summation plus 8. So it will be 16 times the summation, sum, 16 times sum plus 8, right? So that's the function. Okay, should add here semicolons in order to avoid too much information in the command window when we run the code. And then we have to save this file. So we press save, and Matlab suggests that the name of the file has to be the same name of the function. Okay, we already know that, so we save, and then now we will write the main file. So we will create a new script. Since it is a main file, a standard file, we will start by clear and CLC to clear the workspace and the command window, and then we will call the function. First, we set num terms equals, for instance, we can say 20. Okay, and then we call the function and we say, let me again copy this. We will say pi approx will be compute n terms of num terms. Okay, so now num terms, which is 20, will be the input parameter to the function, and then the function will return the approximation to pi that we store in a variable called pi approx. And let's see what happened. We run the code. Now we have to give a name to that file. So it will be problem 2. Okay, that's right, and we save it. And here we get the result. Okay, this is the approximation. If we are interested in the relative error and the number of correct exact digits, we can compute it now. So, for instance, the relative error will be the absolute value of, again, the absolute error, which is pi approx minus pi, divided by the exact value of pi. Okay, and then the number of correct digits, correct significant digits, will be, we call that again Q, as the largest integer, which is smaller than a quantity, and the quantity, according our PDF files, is log 10 of dot 5 minus log 10 of the relative error. So let's see what we get when we run the code. And we see that just using 20 terms in the series, we get 5 significant digits. We can increase the number of digits that Matlab writes in the command window by adding the sentence format long. Okay, so now if we run again, we get a similar result. Okay, but now all the decimal numbers are written with more digits. So just to play a little bit with that, look at what happened when we, for instance, use 200 terms in the series. So now what we get is approximation to number pi with 8 significant digits. Please compare these results with the ones that we got when we use the series that we use in the previous exercises. Okay, So that's all. Thank you very much for your attention and see you soon.